let's go in and build a number plate recognition system. So we're going to use Ultralytics models to go in and detect the license plates. Then we can take that detection, so we take the bounding box, crop it out from the original image. Then we can take that bounding box, crop the image, throw it into OpenAI's vision capabilities to extract the text. You can also use other different types of vision language models, or basically just any OCR scanner, depending on what accuracy you're looking at and also the image quality that you have. But then we can build out this whole system, use the Ultralytics model to get the license plate, throw it into ChatGPT, and then we have this license plate recognition system up and running. So we're just going to jump straight into a Google Colab Notebook. I'm going to run you through it. Everything will be down in the description. We even have a blog post as well, covering like the details about how you can use Ultralytics YOLO11 for automatic number plate recognition. So if you want to see some more details, some different comparisons and all that, definitely go in and check it out. So it can both be used for parking management systems and then combine it with number plate recognition. So that's a very cool computer vision use case. If you go back into our Google Colab Notebook, I'm just going to run you through it. First of all, if you want to use GPU resources, you can go in and use the free ones on a Google Colab Notebook if you go in and change the runtime. So I'm going to connect to the runtime here. It's just going to set up the environment, and then we can just run a few blocks of code and we have this up and running. You can read more details here, but we're just going to use YOLO11 for the number plate recognition. We have a model specifically trained only to extract the number plate from cars driving around, and then use OpenAI GPT model to extract the text. Accurate detection, seamless text recognition, and real-time processing as well. So this will work in real time because it's so fast with the Ultralytics models. You can even go in and just do object tracking. So when you do object tracking, you have an ID, then you can feed that bounding box into OpenAI. You can even do that in async. It can just run in the background, and then once you get the results back, you can attach that to the tracked ID. Then you can track number plates going around in real time. First of all, we need to set up our dependencies. We pip install Ultralytics. That's the only thing that we have to do inside our Colab Notebook. Then we can use from Ultralytics utils download. We can go in and use or download the models and also some examples. So we're going to download this automatic number plate recognition demo video and also the model. So you can just use this model directly out of the box. You don't have to train your own model, but there's tons of different public data sets available out there if you want to train your own model or start gathering your own data set, label it, and then train it here with Ultralytics as well. So if you're going to take a look at it, we're just going to run this block of code that will go in and download it. And if you have some custom license plates, depending on what country you're in and so on, it varies from country to country. So we definitely need to make sure that our data works. That's also why we have this, the license plate detection model is intended solely for proof of concept purposes and may only work with this video demo here. So if you have custom different number plates in your country, you can just scale a whole data set covering all different types of number plates. The more variation you have, the better the models will be at generalizing as well. So after it has installed Ultralytics here and all the dependencies, it's gonna install the models here. So there we go. And then we can read the video file and also the model file. You can read pretty much every single steps that it's doing here, but it's just a few blocks of code and we have this whole system up and running. So now we need to open up a video capture with OpenCV. We just grab the video demo that we have, and we're going to assert that we're able to load in our video. Then we create a video writer so we can see the results from a Google Colab Notebook. We can't run our ImShow in here, but you can do that if you run it on your own local machine. All the code that we have here, you can use that in your own Python scripts in local machine and cloud in pretty much every system out there. So let's just run this here. We're going to create an instance of our YOLO model as well. So we have our video and we have our model. Now we can see that it has downloaded. If we open up our file explorer here, we can see we have this PT, we have our output video, and we also have our demo video as input. We have loaded in the video. This is an example from, or this is basically just an image from the video as an example. We're going to detect the bounding box around the number plate, take that cropped out image, throw it into OpenAI's GPT model for OCR. Now we need to go in and configure the OpenAI client. It accepts a base64 image, so we need to convert it into a base64 image data. So it's basically just bytes that we're going to send with a request to the OpenAI API, and then we get a response back with the OCR results. So only thing that we have to do here is basically go into OpenAI's API, grab our API key and paste it in here. That's all we need. Then we can run this block of code. We're going to extract the text, and we also have the prompt here. Can you extract the vehicle number plate text inside the image? If you're not able to extract text, please respond with none. Only output text. Please ensure no extra formatting. If any text character is not from the English language, replace it with a dot. So yeah, you can go in and modify this prompt here depending on what you want to detect, or if there's any custom stuff in your country or the license plates that you want to detect. So this is the prompt that we're going to feed into it. We have our extract text. This is our base64 encoded data, so our byte data from our image. And this is not the whole image that we feed into it. It's only the number plate. So we get our bounding box. Then we can just slice that number plate out and throw that into the OpenAI API. This is the chat completion we use. We can specify what model you're using. Right now, we're just going to use Mini, but you can specify whatever model. If you just want to run with the larger model, you can specify it in this way. We set up the user as the role, and we have the context, which is just our prompt and our base64 encoded image. So now I've just pasted in the OpenAPI key up here at the top. You can just follow the link as we have in the notebook. Again, the notebook will be down in the description, and then you can grab the API, throw it in here. We have the prompt and we have our extract text. So I'm just going to run this block of code. Now we will process our videos frame. We add some padding as well. So adjust this padding value if needed. Then we have our video while loop just running through our webcam, or no, not a webcam, but our video file. But this also works on a webcam. So you can test that out directly if you have a webcam, other video file, RTPS stream, and so on. We take an image from our webcam, we throw it through our model, predict, we get our 0th batch, and we extract our bounding boxes. Then we both have our bounding boxes and also our classes. We're going to use the annotator to annotate our image with our detections. Then we're just going to run through all the images. So we just have a for loop running through all our classes and all our boxes. So this is the extracted license plates. We have our X1, we have a Y1, X2, and Y2, so that's the top left corner and the bottom right corner, because then we can use OpenCV or NumPy to just go in and slice the image, and then we'll feed that into the system. So now we have our base64 image. We encode it with JPEG.jpg. We encode the image with OpenCV, and we're only able to extract the bounding box, so the license plate that we have detected. UTF-8, we make sure to use that, and now we have our base64 encoded image, which is basically just bytes, and when we have it in bytes, we can send that into a request to OpenAI. So that's what we're doing here, extract text with our base64 image. We get our choices.0, .message.content, so this is how we can extract the actual outputs from the OpenAI API. We print out the response that we get with the extracted text, and then we add that to our detection. We then write out the image to our video file so we can see the results later on. You can even add tracking on top of it. So instead of just using predict here, you can also call track, and it will actually do object tracking, and you can assign these extractions from OpenAI with the number plate to each individual track ID. So it's just running now. We pretty much don't need anything else. We're just going to get the detections. This is just an image with the outputs. So here it's not able to extract it because we don't have high enough image resolution, at least for the OpenAI API to extract the text. We get this one here, and we also get the second one here, but let's see how it works on the video. We see the extracted text here. So it gets 3 number plates. 3 number plates. We can also see it here. We can see the inference speed. So it takes around 50 milliseconds inference. We're running this on a T4 GPU. Now we can see that it has warmed up a bit. So now we run at around 10 milliseconds per image. And right now it's even blocking. So if you have a lot of number plates that need to be scanned at the same time, all of this can run in async mode. Right now we're basically just waiting for our OpenAI request before we process the next image. But you can just process all the images and just in asynchronous mode, just throw all the endpoints, or like throw all the number plates to the OpenAI API, and then you can always assign it to the track ID later on. So yeah, we're just waiting here until let's process the video, and let's take a look at the results. So this is the video results that we're going to get. If we go over here to the left, we can just extract this .avi file, and that's pretty much it. I'm just going to run the video here, and we can see the extractions. So we have a car here, just driving, and this is even in vertical shot. So we have the first one here, this is correct for at least the part that you can see. Let's play it. We even still get the other one. We still have none on the top one here. Here, 3066 MP-4, so that's correct too. Go to the next one. So we have AP4895-5. Let's just go a bit closer so we can see that this is actually correct. And yeah, this is actually correct. So even though it's pretty hard for me to see that this is a 9, we can see that it is a 4895-5. This is very accurate. Like, this is probably one of the best OCR models that you can get. Just feed it into a large language model endpoint compared to like OCR extraction tools. You've probably seen that before. Other different like Easy OCR, Tesseract OCR, all these different OCR scanners. They're not as good as the large language models. So this is pretty much probably the best system that you can get up and running for automated license plate or number plate recognition system. This is how easy it is to get up and running. You can test it out. Definitely go in and check it out. It's just a few blocks of code that you need to set. Take the OpenAI API. Don't have to do anything else. Everything down in the description. Go in and check it out. Then I'll just see you guys in one of the upcoming videos. Until then, happy learning.